Hi everyone, in this video I want to talk about how you'll be able to use normal distribution to calculate other distribution when other distributions are harder to compute by themselves. Okay, let me title this video The Normal Curve in Practice. Okay, so one thing that we usually do to use normal to help us to solve is the binomial distribution. Let me say this. As your sample size n gets large, your binomial distribution kind of become a normal distribution. And the reason we want to use this property is that normal distributions are a lot easier to calculate than binomial distribution where sample size gets big. So this one, it's easier to calculate. I'll do an example to show you exactly how this becomes a lot easier. But before that, let me give you two conditions you need to check before you'll be able to use normal distribution to help solve binomial distribution. So the question is how large we need n to be, right? So how big of a sample size you need. So the rule of thumb for this is you need two conditions, right? So you need your sample size times the probability of getting a success is greater than 10, and at the same time you need your sample size times the probability of failure to be greater than 10. So you need both to be true, right? So you need these two conditions for you to use the normal distribution to solve binomial distribution questions. Then if these are true, then you're free to use normal distribution. Okay. Well, let me just go ahead and do an example to demonstrate how you can use this concept here. Okay, so let me do an example. Example where you're going to roll a die 300 times. Right? So you're going to roll a die 300 times, then n equals to 300, right? Just a very big number. And then the question is, what is the probability you get less or equal to 44 twos? Okay? So you get a 2 and then you record it, right? You get a 2, you record it, and then if you get, say, 1, 3, 4, 5, 6, you don't record them, right? So how many twos or what's the probability that you get 44 twos or less, right? 0, 1, 2, 3, all the way to 44 twos. Okay. So let's describe this question here. So this is a binomial distribution question. If we see it this way, right? So in this case, the success is get a 2, and then the failure is that you get 1, 3, 4, 5, and 6, right? So these are failures. So if you want to get a 2. And then the probability of success, 1 over 6. And then the probability of failure is 5 over 6. Okay. So what's hard about this question? What's hard about question is that the question is not asking you what's the probability that you get 44 2s. But the question is asking you what's the probability that you get less or equals to 44. Which means that in this case, we need to get all the probabilities such that x equals to 0, 1, 2, 3, all the way to 44, right? So we just have a lot of calculation to do. Then it'll be really complicated if we use the binomial distribution. So, very complicated. If we use binomial, okay? So just really complicated. Then we should just use normal, right? Normal is going to simplify this. Use normal. Okay, it's normal. But before we use normal, we need to check the rule of thumb whether we're able to do it. Okay. Check rules. Okay. First one, we need to check n times p. That's equals to 300 times 1/6. That's equals to 50. Greater than 10. Check. N times 1 minus p equals to 300 times 5 over 6 equals to 250. Greater than 10. Check. Right? So both conditions are satisfied, and we're able to use normal distribution to solve this question. Okay, so first, to use normal distribution, we need 2 parameters. We need 2 parameters. We need 2 parameters. The first one is our mean, and the second one is our standard deviation. And this goes back when we talk about our binomial random variable or binomial distribution. The formula for us to get the mean and the standard deviation are, let me do it on this side. Okay. Mu, expected value of the binomial, that's equals to n times p, that equals to 300 times 1/6, that's 50. So that's our mean. And then the variance of the binomial distribution equals to n times p, n times p times 1 minus p, right? So the size times the probability of success and times the probability of failure. And since we want a standard deviation, let me just go ahead and say the standard deviation, just the square root of the variance. Okay, and then that's equals to 300 times 1/6 times 56. Okay, and when we do the calculation, this equals to 6.455, and that's our standard deviation. We have the mean and we have the standard deviation. Now we're ready to calculate. Okay, we're ready to do the normal distribution. Okay, so if we do a graph with these parameter values before we do standardization, so the normal distribution should look something like this. The mean is 50, and then we want the values of 44 or less. So basically, 44 is here, we want the values or the area for here. Okay, so this we can just get the z-score and use the z-table to do. So we can just say the z-score equals to, we want 44, the original value, subtract the mean, and then divided by the standard deviation, 6.455, okay? And this equals to approximately negative 0.93. If we use the z-table, from the z-table, we'll get the value of 0.1762, and then that's equals to 17.62%, which means that the area here is 17.62% here, okay? So that means the probability of getting less or equal 44 twos is 17.62%. Okay, so as you can see, using a normal distribution is just a lot easier to solve this question. Okay, good. So this video talks about how you can use normal distribution to help you to solve a binomial distribution, which is harder to solve by itself in this case. Thank you for watching. I'll see you in the next video.